The future of artificial intelligence is not just about building smarter models. It is about deploying them where they are needed most. We are talking about the edge. The edge is the physical world where decisions happen in real time. Think about autonomous vehicles, smart factories, or distributed robotics. These systems do not run on a single model. They run on swarms of agents that must coordinate without lag. The problem is that every time you add an agent, you add latency. You add communication overhead. You add complexity. For years, the industry has been stuck in a loop where single-model demos look impressive but fail when scaled to a system level. Here is the thing. The bottleneck is not just the inference speed of the model itself. It is how those models talk to each other while maintaining security and trust. This is where the conversation around orchestration tools has shifted. We are moving from community experiments to enterprise-grade infrastructure. One of the most significant developments in this space involves a tool that bridges the gap between the NeMo framework and the physical constraints of edge hardware. It is called NemoClaw. To understand what NemoClaw does, you have to understand where it comes from. It is not a product that appeared out of nowhere. It is the evolution of the OpenClaw AI agent framework. OpenClaw started as a community experiment, a way for developers to test swarm intelligence on GPUs. But community projects have a problem. They lack the security guarantees that enterprises require. They often have installation complexities that make scaling a nightmare. NemoClaw functions as a secure, enterprise-grade plugin designed to resolve those critical vulnerabilities. It takes the core logic of OpenClaw and wraps it in a layer of trust that makes it viable for production environments. Now consider this. Why do we need a specific tool for this when we already have orchestration platforms? The answer lies in the inference optimization. When you are running a swarm on edge devices, you cannot afford the overhead of generic containerization. You need direct access to the GPU cores. NemoClaw leverages the NeMo umbrella to standardize this infrastructure. This signals a broader industry move toward secure AI agent infrastructure that leverages NVIDIA's existing GPU and communication protocols. It is not building a new communication layer from scratch. It is optimizing the protocols we already rely on. Let's talk about the communication layer specifically. The backbone of high-performance GPU communication is the NVIDIA Collective Communications Library, or NCCL. This library handles the data transfer between GPUs. In a swarm scenario, you have agents sending data to each other constantly. If the communication protocol is slow, the intelligence of the swarm is useless because the agents are waiting on each other. NemoClaw integrates deeply with NCCL to manage these protocols. It optimizes the handshake between agents so that the latency is minimized. This moves the conversation beyond single-model demos to system-level latency and throughput trade-offs. You are no longer measuring how fast one model answers a question. You are measuring how fast a team of models reaches a consensus. Security is the other pillar of this architecture. In the past, running proprietary AI models on shared hardware raised concerns. What if someone intercepts the model weights? What if they inject malicious data into the inference pipeline? This is where GPU confidential computing comes into play. NemoClaw acts as a bridge to these security features. It represents a strategic shift by the manufacturer to transition the AI agent framework from a community experiment into a supported platform with enhanced confidentiality and trust mechanisms. This means the data remains encrypted even while it is being processed. This is critical for edge devices that might be physically accessible or operate in untrusted networks. There is another layer to this development that often gets overlooked. It is the compatibility across hardware ecosystems. For a long time, deep learning was tied tightly to specific NVIDIA hardware. But the industry is moving toward flexibility. Key development trends indicate active community-driven adaptation, including specific efforts to resolve compatibility gaps for non-NVIDIA hardware ecosystems like Apple Silicon. This is significant because it means the orchestration logic is becoming portable. You are not locked into a single vendor silicon to run your swarm logic. The rebranding and re-engineering of the framework under the NeMo umbrella signals a move toward standardization. You can build the agent swarm once and deploy it across different edge devices without rewriting the core communication logic. Think about the implications for throughput. When you optimize for latency, you often sacrifice throughput. When you optimize for throughput, you often sacrifice latency. NemoClaw attempts to balance these trade-offs. By offloading the orchestration overhead to optimized plugins rather than general-purpose schedulers, The system can maintain higher throughput without the latency spikes that usually accompany swarm coordination. It is like upgrading the traffic control system in a city. If every car has to stop at every intersection, traffic moves slowly. If you have a synchronized light system that coordinates the flow, traffic moves faster and more efficiently. NemoClaw provides that synchronization for AI agents. This shift changes how we think about deployment. Before this, operations teams thought in terms of servers. They managed individual machines and hoped the software on them would talk to each other. Now they think in terms of workloads and agent swarms. The tool handles the rescheduling automatically. If a node goes down, the swarm reconfigures itself. The agents find new partners. The system recovers without human intervention. This resilience is what separates a prototype from a product. The impact of this technology extends beyond just speed. It extends to trust. In an era where AI models are being deployed in sensitive environments, the ability to verify that the inference is happening in a secure enclave is paramount. NemoClaw resolves the installation complexities inherent in the original framework, making it easier for security teams to audit the system. It turns a black box into a transparent, verifiable pipeline. This is why the rebranding under the NeMo umbrella is so important. It brings the maturity of the NeMo framework to the agent orchestration layer. It tells the enterprise that this is not a research project anymore. It is a supported component of the infrastructure stack. As we look at the next few years, the distinction between model development and system orchestration will blur. You will not be able to build an agent without a secure communication layer. The tools that provide this integration will become the standard. We are seeing a convergence of high-performance computing, secure enclave technology, and flexible orchestration logic. The result is a system that is faster, safer, and more reliable. The journey from OpenClaw to this current iteration shows a clear pattern. It shows an industry that is maturing. It is taking the raw power of GPU cores and wrapping it in the security and reliability required for real-world use. It is acknowledging that the edge is not just a place to run code. It is a place where data must be protected and decisions must be made instantly. This is the new standard for autonomous systems. It is the foundation upon which the next generation of intelligent infrastructure will be built. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.